Welcome here. It is Monday, April 20th, and another edition of Kitchen Table Chemistry. Today's topic is gas stoichiometry. Gas stoichiometry is the combination of the ideal gas law and stoichiometry together. As you already saw with the examples I gave you in the notes, you're going to be combining or hooking this up to a traditional stoichiometry problem where we traditionally had used 22.4 liters at standard temperature and pressure, but of course we're not obligated to do that now because we understand how to solve without using standard temperature and pressure. So we may start or end with the ideal gas law. And this depends on if we're starting with a gas or ending with a gas. So this part here is the sort of the difficult to understand. Are we using the ideal gas at the beginning or the end? And I'm going to show you both methods here and how you can tell them apart. So here we go. How many liters of hydrogen gas will be produced from the reaction of 3 grams of zinc? So we're starting with 3 grams of zinc, which means we're going to end with the ideal gas law because we're starting with a solid 3.00 grams. And we're asked to find the volume of the gas. So we've got a balanced reaction. That's crucial. We then take this balanced reaction and we're going to take the 3.00 grams of zinc. And like we've always done before, we're going to turn it into moles of zinc, 1 mole of zinc, 65.41 grams of zinc. Now we're going to go into moles of hydrogen, and add so 1 mole of hydrogen from the balanced reaction for every 1 mole of zinc. And this is as far as I want to go. So what I get now here is 0.0459 moles of hydrogen, moles of H2. What I'm now going to do is use this to put into the ideal gas law, PV is equal to nRT. And I've got this number of moles now that I've figured, 0.0459 moles. And I'm asked to find the volume of this, so that's the unknown. The pressure given in the question is 0.911 atms, a little less than 1 usual, times 0.0821, the R constant, which will be liters times atmospheres, over moles times Kelvin, times our temperature, which is 45, which would be 318 Kelvin. And then I'm simply going to solve for volume, and volume here algebraically ends up equaling as 1.32 liters. And that is my answer for the volume of gas. Why did I end with the ideal gas law? Because I was given the grams of solid to start with. That's why we ended with it. But what if we're starting with a gas? So we would logically then have to start with the ideal gas law. And presto, here is an example. How many grams of magnesium carbonate would I get if I start here with 2.50 liters at 110 kPa and 25 degrees Celsius? Excess magnesium oxide, so we don't need to worry about that. So I'm going to start off then by solving for moles of this. That is what I need to find. Moles is the initial X I want to find before I can go and find grams of this. So I will take my P, yikes, go back, off the screen there. My PV equals nRT. And my pressure, which is 110 kPa, times the volume, which is 2.50 liters, is equal to N, which I don't know. And I'm going to be dividing that by R, which, because I'm in kilopascals, is 8.31. And times T, which is 25, so that would be 298 Kelvin. And then I'll get this N value for how much I will need, and it's going to be 0.111 moles of CO2. So using that to start with, I've now got my moles of CO2. So stoichiometrically 0.111 moles of CO2. And now we're going to go and solve for moles of magnesium carbonate. 1 mole magnesium carbonate for every 1 mole of CO2 that's put in. And then to get to grams of it, because magnesium carbonate is a solid, we'll use 84, I used 84 point, check, 3 grams of magnesium carbonate for every 1 mole of magnesium carbonate. And this will get me an answer here. And I got a value of 9.36 grams of magnesium carbonate. That is how much we will end up being able to produce from that gas with the excess. All right, that's how we that's how we start with the ideal gas law because we were given a gas to start with. So we started with the ideal gas law. That is the two different ways of doing this. I've given you 5 examples, which is a few, definitely a few. And so please go through those 5 and practice with them. I find that if you practice it, you will get used to whether you start or end with the ideal gas law. You have to think about what you're doing. I wish you the best of luck on this Monday. I hope you're doing well and you're not too bored with being quarantined. Email me with any questions or things like that. As I put in the announcements, we're looking at a quiz probably tomorrow on the ideal gas law, smaller quiz than last time. And that I don't know that I'm going to do a multiple choice. I think I'm just going to give you some questions to do, and that like we typically would. Hope you're having a great day. Take care, guys. Bye bye.